nucleus atomic mass. Suppose, what do you mean by, how do you write the symbol of an element? Okay, that you have studied and you know that suppose this is sodium, got it? And how you write it? 11 and 23. Okay, so what this 11 means, what this 23 means? Just little bit idea if you have, you can give me, or I can explain you, no problem. Just you can ask me any number of times, you can stop me any number of times, right?
Yes, sir.
Okay.
So 11 is the atomic number of
Exactly. Yes, very good. Atomic number.
and 23 would be atomic mass.
That is the atomic mass. Yes, exactly. So you have the nucleus of the sodium, and nucleus will have contain what?
Protons and electrons.
Yeah, protons and neutrons. Okay. So this is the number of P and N, and this is the number of T. Got it?
Yes, sir.
Yeah. So we are having 11 protons, right? So 3. Eleven protons, and how many neutrons will be there?
12.
Exactly. So 12 neutrons. Okay. So this is the sodium nucleus. Okay. And you have electrons moving in fixed orbit. Okay. Around the nucleus. Got it?
Yes, sir.
So we are having 2. Then you have 8. And electron normally how much they will be? What is the number of electrons? Number of electron, because there is no charge mentioned over here. Protons are positively charged. Okay, plus E. Okay. So
Yes, sir.
protons have positive charge, +1 charge, or you call it plus E. Clear?
Yes, sir.
So is there any charge mentioned on the symbol?
No, sir.
No. Means the charge is neutralized. Electrons is having -1 charge, so the number of electrons should be equal to the number of proton in a neutral atom. Is it clear or not?
I can't properly hear you, sir.
Okay. Protons are positively charged, right?
Yes, sir.
And electrons are negatively charged. Okay.
Yes, sir.
And in a neutral atom, both should be equal. In a neutral atom,
Yes, sir.
number of protons equal to number of electrons. Why can we say this? Because atom can remain neutral only if the protons and electrons are equal. Protons have positive charge and the electrons have negative. Is it clear?
Yes.
So you had 11 protons and because there is no charge written on the sodium, so there will be 11 electrons. Okay, the proton will carry plus 11 charge, electron will carry minus 11 charge, both will be equal. That's why it is neutral.
Okay,
Understood?
sir.
Okay, great.
Yes, sir.
And the number of neutrons, you subtract 23, and from 23 you subtract 11, so you get the number of neutrons. So you have 12 neutrons. This number is known as mass number. Okay, mass number, because the mass of an atom is because of protons and neutrons only. Is it clear? Electrons have negligible mass. So while considering the mass, you consider only the sum of protons and neutrons. So electrons have negligible mass, so they are not counted in mass number.
Okay, sir.
So, and due to that, their mass is not taken into account. Is it clear or not?
Yes, sir.
It's not taken into account. Okay, great. So sodium, so I hope this is clear. Now you can write for any of the element. For example, if I give you aluminium, which is having, it is a 13th element. Okay. So how many protons are there?
So 13 protons.
Exactly. Very good. Neutrons will be?
14.
Yes. Electrons will be?
13.
Normally they are 13. But the positive charge is 3 more. Okay, plus 3. So means electrons are less in number. So number of electrons equal to number of protons minus charge. Charge you need to write with a sign. Is it clear?
Yes.
This is the formula. So plus 3 is there, minus 3, it will come down to 10. It means the proton are 3 more than the electrons. Got it?
Yes, sir.
So that suppose if you have, let's say, if you have Li3 plus, okay, Li3 plus, or it is the third element. Okay, its mass number is 7. So how many
Okay.
protons are there? Neutrons are
3
there?
protons.
Yes, 3 protons, and neutrons
4.
are 4. Yes, electrons are?
0.
Yes, 0. Electrons will be protons minus charge. Charge you need to write with a sign. So 3 minus 3 equal to 0. Correct. So now you understood this completely. Okay.
Yes, sir.
Now I will tell you what is atomic mass. So, and what do you mean by atomic mass? First you tell me, then I can discuss it in detail.
Mm.
Hmm. Any idea?
Yes.
Okay, no problem. Atomic mass, suppose though it is not possible. Imagine if you can pick just one atom. Okay, if you pick just one atom, single atom. So whatever the mass of that single atom is known as atomic mass. Is it clear? So atomic mass, for example, for sodium, Na. And just now I told you that for the mass you need to take into account the mass numbers. Electrons are not counted in mass. Okay. So it is 23 particles are there, proton and neutrons. And what is the charge of one particle?
One
Charge of
proton.
one, yeah, on neutron. That is called U. 1 unit charge. 1 unit mass, not charge. 1 unit mass. The mass of proton is 1 U or 1 unit or one atomic mass unit, you call it. They are same. Or the mass of the neutron, that is also approximately 1 U. Is it clear or not?
Mm.
I will suppose you have this. Let's get back to the picture. Okay. So you have protons and neutrons. The proton's mass of the proton is approximately equal to 1. Mass of neutron, that is also approximately equal to 1. Okay. Electrons have negligible mass, so don't take into account while counting the mass. U is some unit. Okay, I will explain it what is U. Okay. As of now, you can consider it as just 1 unit. Okay. So if each proton has a mass of 1 unit and neutron has a mass of 1 unit, what will be the total mass of the sodium atom? How many protons were there? I think you are muted.
Yes, sir. It was low internet.
11 protons. Okay. And how many neutrons are there? 12 neutrons. Got it? So what is the mass of 11 proton? That will be 11U, because each proton was carrying a mass of 1 unit. Each neutron was also carrying a mass of 1 unit. So what will be the total mass? 23 units or 23 AMU. Is it clear or not?
Yes, sir.
Mass, atomic mass, this is the definition. Mass of a single atom when expressed in terms of U. That is called atomic mass.
Okay, sir.
So suppose if I take helium, Helium is this. What is the mass of a single helium atom? Or what is the atomic mass of helium?
4.
Yeah. So mass of a single 4. What is what should I write it?
U.
4U. Yeah. Okay. But
Yes, sir.
mass, till now we know that mass is measured in grams or kilograms. But
Hmm.
we don't know what is U. So we need to express U in terms of grams. One U is 1.67 into 10 to the power minus 24 grams. Is it clear or not?
Yes, sir.
So how will you define U?
U is
Define
the
U.
unit for
Hmm.
U is the unit used for mass of a
Yeah,
single atom.
yeah, yeah. It is also known as atomic mass unit. U is also known as AMU. It is roughly equal to the mass of a single proton or a single neutron. In order to get the atomic mass, we add the number of proton and neutron and we express in terms of U. Is it clear or not?
Yes, sir.
Okay. Next is suppose suppose if you don't round off, it is 1.66 into 10 to the power minus 24 gram, or if it is 1.66 into 10 to the power minus 27 kilogram. But we don't use kilogram, we use grams only. So why we have not expressed U in terms of grams? Why we
The
are
very
expressing
small topic.
why we are expressing the mass in U only? Because it is comfortable to add the masses of atoms. Suppose if I write it this, or if I write the value, actual value, which is more easy to handle. Is it the mass in terms of U or the actual mass? What is the actual mass?
4.
Yeah. Suppose if somebody asks you that, okay, give me the mass in grams, what you should say?
You should multiply 4 with the value of U.
Yeah, value of U exactly 1.66 into 10 to the power minus 24 grams. You will get the actual mass.
Okay, sir.
But in chemistry, we actually do the addition of masses in the chemical equation and all, right? So will it be easier for us to express the mass in terms of the actual mass, or will it be easier for us to express the mass in terms of U?
In U, sir.
In U, that will be very easy for us. So, and it is very easy to find what is U, what is the mass in terms of U. Just add the number of protons and neutrons, okay, and put U uh, with the sum of the protons and neutrons. I hope this is clear. Okay, great.
Yes, sir.
So this is 1U, and IUPAC says 1U is 1/12 of the mass of carbon. This is the IUPAC definition. If you take one carbon atom and if you its mass just divided by 12, that is 1U. Okay, this is not useful.
Okay.
Just if somebody asks you what is 1U, define 1U, you will say approximately it is the mass of the one proton or one neutron. How it is, what is the IUPAC definition? Then you should write this. Okay. right? Otherwise, let it continue in this manner. Then
Okay.
next thing is Nabeela, how you count the number of particles? There is also how do you count the number of particles? Is there any unit of counting you are aware of?
No, sir.
Okay, no, you are aware. Like dozen. What is dozen?
That's it. 12.
Yeah, dozen is 12. That is also counting unit. You know that, right?
Yes.
Right.
Yes, sir.
Pair.
2.
Exactly. Okay. Now, because we already have counting unit, but the problem is now we are going to count what? We are going to count atoms, ions, molecules. Okay. And their number is huge. They are present in huge numbers. Okay. For example, if I put a dot, I put this dot, okay, on the screen. Or if you put a dot with your pencil in your copy, it will have, the pencil is made up of graphite, you know that, okay, lead, that is made up of carbon. So it will have 10 to the power 20 carbon atom, just one dot. Such a huge number because atoms are so small. If I want to count them, I need a very big unit. Okay, is it clear or not? And that unit is
Yes, sir.
1 mole. Is it clear?
Yes, sir.
1 mole. So 1 mole should contain 12, 2. These are very small numbers. 1 mole contain how many entities or how many units? It should contain 6.022 into 10 to the power 23 entities.
Good.
Is that clear? Okay, it
Yes,
is a
sir.
very, very, very huge number. Very large number, 10 to the power 23. How large is it? Suppose if you ask for your father to give you 1 mole dirham of pocket money, right? And if you spend 10 lakh dirhams per second, okay, it will take 10 to the power maybe 9 years or more than that to spend all the money. 10 to the power, so much, such a big number. If you are spending 10 lakh dirhams per second, okay, it is a very big number. Okay, so but why we are dealing with such a big number? Because we are counting atoms, ions, molecules. Atom and molecule are very small, and this, even in a small dot like this, you can have many large number of atoms. So in order to count them, we need a unit which should be large enough. Okay, so 1 mole is 6.022 into 10 to the power 23 entities I have written. It is a general thing, means if you are counting the molecules, entities will be molecules. If you're counting the ions, it will be ions, right?
Yes, sir.
If you are counting electrons, 6.022 into 10 to the power 23 electrons, you can count anything, even the day-to-day life object. But day-to-day life object, it doesn't make any sense because day-to-day life objects are too big and we can't have that many objects with us. Okay, So it is just like a dozen, but dozen had just 12 units, pair had just 2 units, and this is having a very large number of entities. Okay. So what this number is known as? Any idea what is the short form abbreviated name of this number? It is represented by NA. Okay, and its name is Avogadro. So till now, what you know about mole? Just can you explain me very briefly?
One mole is having a unit of 6.022 into 10 raised to 23 entities. And this value is from the Avogadro's
Yeah,
law.
this is known as Avogadro's number. Yes, NA. Yes, correct. So with one mole, actually you are measuring the mass or you're counting the number of particles. It's a unit
Counting the number.
counting or it's a unit of mass. Yes, it is a unit of counting. Okay, mass means how heavy something is, and counting is one by
Yes.
one we are counting how many are. Okay, what we are counting normally in chemistry we are bothered mainly about the atoms, ions, molecules. So we are trying to count them. Got it?
Yes.
Okay. So you are not feeling well.
Yes, sir.
Okay, no problem. Hope you will get well soon. And just
Thank you, sir.
in case if you need a break, just let me know. Okay. So this I hope is clear, right? Okay.
Yes, sir.
So mole is a unit of counting. So we group in terms of moles. Okay. Because it is easier to group large number of entities in terms of moles. Okay. For example, if you want to measure the mass, it is easier to express in terms of U. If somebody we wants it in gram, we will say that okay, put that value of U and get yourself in the grams. Okay, but we will express in terms of U. So I hope this is clear. Okay.
Yes.
Now we introduce one more thing: molar mass. What do you mean by molar mass?
Mass of the molecule.
Molar mass. It is the mass of 1 mole of entities. Suppose if I give you 1 helium atom, okay. So what is the mass of just single helium atom? 4U. Got it?
Yes.
Okay, that very correctly predicted. And if I ask you the mass of so is it just a single atom or a huge number that the whole group of atoms? It is the whole group of atom, that group of atom, and how many it contains? It contains, yeah, 1 mole. How many helium atoms? Okay, very large number. Very large number. I can't draw them. Okay, I need many billion years to stay alive to draw all those helium atoms. atoms. Okay, which is a very large, right? How many are there? 6.022 into 10 to the power 23 helium atoms. So mass of 1 mole of helium atom is mass of how many helium atoms?
Oh,
Mass, it is the mass of the whole bunch of helium atom. That bunch consists of 1 mole of helium atom. That is 6.022 into 10 to the power 23 helium atoms. The helium atom, the number of which is equal to Avogadro's number. Okay,
yes.
it is known as the mass of whole bunch. Whole bunch means 1 mole, and that is called molar mass. Now, have you understood the meaning? The mass of whole bunch of 1 mole of entities. Is it clear or not?
Yes.
So it is, but the it appears very difficult, but it is very easy. Molar mass of helium is again 4, but now the unit has changed, 4 grams. Got it?
Yes.
Earlier the unit was 4U. U was the atomic mass unit that was used to measure. This is actually 4 into, this is 1.66 into 10 to the power minus 24 grams. Got it? This is not 4 grams, it is a very small number. But if you take one whole bunch of, bunch means that 1 mole of helium atom, the figure remains the same, that 4. Okay, 4 remains the same. And the mass now for whole 1 mole is going to be 4 grams. Got it? Is it clear or not?
Yes, sir. Yes.
Right. So I hope this is clear. You understood very well. Okay, in spite of your not feeling well. Okay, so I really appreciate your efforts. Keep it up. So this is, I hope it's clear. Okay, molar mass. So we can take one more example of sodium, let's say, because we are continuing with the sodium. So one atom of, if you try to measure the one atom, mass of one atom, just one atom, 23, okay, and the mass of what it will be. Mass of Na sodium atoms, it will be
23 into
23,
0.6.
yeah, grams.
Mm.
Just write it like this. The figure remains the same, 23. One is in U, another is in grams. Is it clear? No.
Yes, sir.
Okay, great. 23U and 23 grams. So how can you get to this value? From one atom to 1 mole of atom, you need to multiply it with Na. Because that was the mass of single atom. And this is the mass of how many atoms? Whole bunch, that 1 mole of atoms. Okay. So you need to get to that, you need to multiply 23U into N. And U into Na is 1. Okay. 1 gram.
Okay, sir.
So that's why you got 23 gram. But you don't need to get to this calculation every time. Just you need to keep in mind. For example, if I take neon, this is the 10th element. It is a noble gas whose mass is 20. Mass number is 20. If I talk about the atomic mass of neon, what it will be? Atomic mass
20.
20 U. Yes, very good. If I talk about the mass of that whole bunch of 1 mole,
Is 20 G gram.
20 grams. Yes. And it is 20 U, which is a mass of 1 into Na, and that is U into Na is 1 gram, 20 G. Got it? So this
Yes.
is the molar mass and the atomic mass. Mole, which is a unit of counting. So suppose if I give you some number of atoms, number of entities, can you tell me how many moles you are having?
Your voice is
Yeah, your connection I think is a bit slow. Yeah, just a second. Am I audible, Nabeela? No.
so.
Yeah. Yeah. Okay. Your actually video froze. Now it is okay. You are able to hear me?
It's breaking, sir, but now I can hear.
Okay. So you know the mass of 1 mole of entity. So you can calculate the moles. Moles you can calculate from what do you understand by this? What I have written.
The neutron, the number of mole, or
Yeah,
just
n is the number
number.
of moles. N represent number of moles in a given mass of substance.
So the mass would be given.
In a given mass. Number of mole in a given mass is mass in grams. Given mass divided by molar mass. Okay, it is just like how this formula came. It's very simple. Suppose you have a box. Okay, and that box, the mass of the box is 10 kgs. And there are apples in it. One apple has a mass of 1 kg. How many apples are there? What you did?
We will
That whole mass was 10 kgs, and mass of one apple you knew that was actually the mass 1 kg. So how many apples are there? Number of apples. What you did?
10.
Exactly. 10. That is the total mass of the given mass divided by the mass of one. one apple. Okay. So here also you are going to do the same thing. Given mass in grams divided by mass of 1 mole. Here you took the mass of one apple. Okay, there you took the mass of 1 mole because you need to find the number of moles. Are you getting my point or not?
Yes, sir.
Suppose if I give you 20 grams of helium gas. I give you a balloon, okay, and that balloon has 20 grams of helium filled in it, right? Now, if I
Yes.
ask you that how many moles of helium gas are there in that balloon?
20 by 4.
So what you will do? Yes, exactly. 20 grams. That is the total mass given to you. And how many moles you divide by the mass of 1 mole. Okay, the same way you did here, right? Same thing you
Yes.
are going to do. So you are going to divide. What is the mass of 1 mole?
It's 4.
4 grams. So how many mole are there?
5.
Exactly 5 mole. Okay. So always remember, number of moles you can find by measuring the mass of a substance, but total mass which is measured should be divided by molar mass to get the number of moles. Okay.
Yes.
How can you find the number of moles?
Mole.
Moles from the given number of entities. Means suppose if I give you actual number of entities. Suppose if I give you, I am having 36 apples and I ask you how many dozen. What you will do?
Divide by 12.
Yes, very good. 36 divided by 12. Because that group made one dozen. So in order to make out how many dozens are there, so the total number divided by the number which consists of one dozen. Okay, which constitutes one dozen, so 3. Clear? That you already know very well. Okay.
Yes, sir.
Same thing you can apply for the mole also. If, but you need to be very careful if the number of entities are given. So first I write the formula. Number of mole n equal to number of entities divided by Avogadro. I hope this is clear.
Yes, sir.
The same thing which you did for dozen. But dozen had 12 entities, so divide by 12. But in order to find the mole, you will divide the number of entities by Avogadro.
Okay.
So number should be divided by number and mass should be divided by mass to get the mole. If the mass is given, divide by molar mass. If the number is given, divide by. If the number is given, divide by Avogadro number. Number should be divided by number to get the moles. Got it? Is that clear to you?
Yes.
Okay, good. So now suppose if I ask you, Nabeela, suppose if I'm having, let's say, 6 into 6.24. Make it 20. And if I ask you to find the moles, so you have relationship moles. From the number you can find number divided by Avogadro to get the moles. If you want to do the calculation with the number, you can use this. If you want to do the calculation with the mass, do this. Got it? Is it clear or not? Right?
Yes.
Mass divided by molar mass or molecular weight also is written in grams to get the moles. So don't try to calculate directly. Suppose if I have given this, first get back to the moles, then use the mass formula. So first tell me how we will solve this.
It's the moles are given. Sorry. N equal to
Number of helium atoms are given.
So write N equal to the given
N equal to given number.
Avogadro's number.
Yeah, upon Avogadro. So given number is 10 to the power 24 upon Avogadro number 022 into 10 to the power 23. Got it? They are same. Avogadro number is just having 10 to the power 23, 6.022 into 10 to the power 23. Is it clear or not?
Yes. Yes, sir.
So this will get cancelled completely. This will get cancelled. Just one zero will be left. Okay. So 10 more. Oh,
Yes, sir.
so this I hope is very clear to you. Okay.
Yes, sir.
Next is suppose if I ask you what is the mass of these many helium atoms. So from you would not go directly to the mass. First you will come down to the moles. Now you will use the formula which relates the mass with the moles. So moles equal to mass by molar mass.
Yes.
Number of moles are how many? 10. And mass is, it is asked in the question. So we don't know what is the mass. We know the mass of one atom. That is true. That is 4U. Okay. What is the molar mass? That is gram. Okay, molar mass is in grams, right? So mass is equal to 4 into 10. Or you can directly also simplify that mass of 1 mole was 4 gram and 10 moles was 40. Mass of helium. Is it clear?
Yes, sir.
So let's take a break of 2-3 minutes and let's join the class, but don't worry about the topic. Okay, I am doing the concentration terms. I will explain, and whatever is not clear to you, I will explain it again in the separate classes we can schedule. Right? So, but
So
you
today
did
we have the extra class,
today you will attend in the regular class. Okay, now which is
the batch
from,
class.
yeah, the batch class, and that is for 1 hour. And after that, we will have some diagnostic test just for half an hour or 15-20 minutes, just a normal discussion. Okay,
Yes, sir.
and we will be able to finish in 1.5 hours. You can take little bit break. Okay, so we can start in 2-3 minutes. Okay, you can come back. Okay.
I will go and come back. Sorry. Pray and come.